think that's it for housekeeping. With that, I'll go ahead and introduce our distinguished speakers for today. In 1990, Ravi Arulanantham joined California Regional Water Quality Control Board as their first toxicologist and provided expertise in expanding the application of risk assessment and risk management to the areas of policy development, case review, and staff training. He's been the principal instructor for Cal EPA and State Water Resources Control Board sponsored training courses on risk-based decision-making at contaminated sites. These courses have attracted more than 2,000 regulators, consultants, and responsible parties throughout the state, significantly affecting the movement of consultants and regulators toward accepting risk-based findings as a component of decision-making and site closure. Ravi is among the few ASTM-certified national trainers for both the Risk-Based Corrective Action Program and the Remediation by Natural Attenuation Standard, and has trained over 1,000 regulators, consultants, and responsible parties in more than 20 states. In late 2010, Cal EPA appointed him to a committee tasked with developing a low-threat petroleum case closure policy. The low-threat policy, after going through University of California peer review, was adopted and became effective in August 2012. Ravi Arulanantham was a Fulbright Scholar at the University of California at Berkeley, where he received his master's and doctorate in physiology and biochemistry in 1988. Matthew Cohen has 14 years experience with investigation and remediation of soil, groundwater, and soil vapor at the State Water Board and in private consulting. He received a bachelor's degree in geology from San Francisco State University and is a registered professional geologist. Mr. Cohen is currently the program lead for the underground storage tank cleanup and GeoTracker unit in the Division of Water Quality at the State Water Resources Control Board. He manages the development of statewide policies and procedures, review of closure petitions, and the maintenance and development of the GeoTracker database. Hannah Phillips graduated from Metropolitan State University in Denver, Colorado, with a bachelor's degree in environmental science. She worked for an environmental consulting firm, managing petroleum remediation sites for 7 years. Ms. Phillips came to the state of Colorado in 2018 as a technical reviewer in the petroleum remediation section. Currently, they are implementing risk-based corrective action principles to close out legacy releases when the risks to human health and the environment are not present. And finally, Laura Luther graduated from the University of Missouri-Rolla with a bachelor's degree in chemistry. She received a master's degree in adult education and distance learning from the University of Phoenix. Laura worked for 11 years in environmental labs as an analytical chemist, and she's been with Missouri DNR for 15 years in the tank section. Ms. Luther oversees the Missouri Rebecca process for about 800 regulated petroleum storage tank releases. Please help me in welcoming our speakers. I know you can't clap electronically, but I'm very happy to have all of these speakers here with us today. Just a quick overview. We'll have a brief recap of Unit 1. As I mentioned, this follows a previous training. Excited for the Q&A with our panel. We'll talk about Rebecca and the 3 states represented, and Ravi is going to lead that discussion. And then if we do have time, toward the end, we have a case study from California that we'd like to share with you as well. And with that, it's my pleasure to introduce Ravi Arulanantham.
You can load these.
You guys got the controls there? I just handed them off, I believe.
Can you see the slide?
Yep, I think we're good to go.
Good morning and good afternoon, ladies and gentlemen who are joining us in the workshop. My name is Ravi Arulanantham. Don't try to pronounce my last name, just say Ravi if you want to ask questions. So I want to take a few minutes to recap the first training that we did almost a year ago, a little over a year ago, which was the basic risk-based training based on the ASTM standard and generally accepted risk-based standards. So that was done by Atul and myself in October 2017. And so I'm going to go through a few slides. For those who attended the workshop last time, this is a recap. And for those who did not attend the workshop, this is an introduction to what is risk-based decision making. You're trying to move the next slide, just be patient. So Drew, have you given us the, to move the slides?
Yep, yeah, you should have it if you hover your mouse on the left side of the screen. Do you see the 0, 1 and the arrow button? Be able to click down.
I see.
Yep.
Okay. So this slide is a general story of a gas station anywhere in the country. You can see a gas station in between schools, homes, residential areas. You can see gas stations leaking, and there are utilities, shallow utilities, little deeper utilities. There's a small groundwater plume there. You can see some abandoned wells, future domestic wells, current shallow wells, and deep municipal wells, streams. This is a cartoon that I drew a long time ago just to show the story of a typical gas station. So these are all unique factors, attributes that you need to take into account in making a decision in any releases from gas stations. Sometimes water table is shallow, sometimes water table is deep, sometimes there is a downward gradient, there's an upward gradient, sometimes you have, in the East Coast, you have a lot of fractured rock. In California, we have heavy clays in the pore base, and in the valley, you have a huge vadose zone, very permeable vadose zone. So all of these are attributes that you need to consider before you can make any decisions on any site. So this is the story of the sources, the pathways, and the receptors. So the source is the primary source is the tank. The secondary source is the release from the tank that is in the vadose zone and in the groundwater. The pathways are the preferential pathways, utilities, abandoned wells, domestic wells, municipal wells, and the receptors are mostly human and animals and plants. So this is the story of the sources, pathways, and receptors. So you have to really frame this picture before anyone can make any decisions on, any risk-based decision making in any cases. Very important is this picture will give you, will put in front of you these following questions. Who are we protecting? What resources are we protecting? How soon we need to protect these resources? Because if you start thinking in terms of what resources am I protecting, who am I protecting, how soon, it'll be a very different decision to what level I need to clean it up, or the old paradigm of just come and clean it up to some comfortable numbers. So this picture gives you a story and allows you to frame your thinking thought process before you move into decision making. Next slide, please. This decision-making process has three main components: site characterization, risk assessment, and risk management. In the old paradigm, when I was a regulator many years ago, I would first come, start putting wells, and would take samples in a site. Then after 4 or 5 years of characterization, then the client will ask me, what do I need to do? Then I will tell them, go and do a risk assessment at the site. Then those days, the risk assessment were very sophisticated, and we would do a risk assessment. And then what do you do next is do something about, which is risk management. In the new paradigm, So in the old paradigm, can you go back to the slide one more time? In the old paradigm, site characterization drives risk assessment, and risk assessment drives risk management. In the new paradigm, it is risk management that drives risk assessment, and risk assessment drives site characterization. It's a very important and valuable lesson we learned over the years doing this program, that we have moved away from site characterization driving risk assessment and risk assessment driving risk management in most of the brownfield sites, and in the advanced when you try to integrate land use, water quality, and cleanup, it's risk management that drives risk assessment, and risk assessment drives site characterization. Very important is the middle one, causes regulatory policies and procedures. So each state needs to facilitate the regulatory policies and procedures that allows this triangle to move very smoothly function. Otherwise, you will get into very sticky situations and get back to the old paradigm of sampling, remediation, and you really don't have an end point for these sites. Next slide, please. So all of this is embodied in something we call a conceptual model. I am sure every state now have this site conceptual model or conceptual site model. Preparation of it and validation of it is the primary work that you do in the beginning. It's a narrative and graphical description of site characteristics. It identifies general and specific physical conditions that influence the transport. We talked about earlier the pathways, and it identifies the environmental issues that need to be investigated. These are the who are we protecting and what resources are we protecting. Next slide. It also allows us to design the best remediation options rather than going and wasting your money and time and doing redundant work. It allows you to surgically allow you to go and do remediation that will reduce the risk as well as the time to get the plume quickly get exhausted. So conceptual site model is the cornerstone of a good risk-based decision making. Every state has it now. I'm sure EPA has been putting a lot of resources trying to trickle down this knowledge of everybody start with a good conceptual site model, and a lot of tools have been provided to many states to implement a good conceptual site model. Ideally, it should be developed by regulators and PRPs together day one, and including stakeholders sometime, so that it becomes a very transparent process. If you don't do this upfront with regulators and stakeholders, it becomes not a very transparent and not a very easy communications tool. Next slide, please. Okay, risk assessment asks two questions. Ideally, would like to clean properties to pristine conditions. Everybody wants their state, their towns, their homes to be very pristinely cleaned up. However, extensive experience, including the National Academy of Sciences, several reports from the NRC says technology nor resources exist to clean sites to pristine conditions. Especially, you cannot fight with Mother Nature at very low concentration. The National Academy of Sciences came very clearly said this many years ago, that achieving these levels is not technically feasible. The next one is not necessary to clean to pristine condition. Very hard to swallow this statement. Nobody wants to know that I'm living in a polluted environment now. But if you start thinking in terms of risk, you really don't need this is a very philosophical discussion. You don't need to clean it to pristine condition, because today in California, I'm breathing benzene more than the EPA's allowable level. Right now, the whole state of California's air is polluted above EPA levels, and we are breathing it. It's not pristine anymore, but it's below the risk levels. So we all go about our life every day in California. So risk assessment is used to answer these two questions. What is the risk at the site, and how clean is clean. So this was something that we covered last time in our session in more detail, but I'm going through some recap. Next one, please. The application of risk assessment is a very scientific and a regulatory process. It's not 100% science. There's a lot of policy decisions married with making a risk assessment statement. Risk assessment can be done in two modes. One is called the forward mode of risk assessment. The other one is known as the backward mode of risk assessment. The forward mode of risk assessment is the traditional baseline risk assessment. You go to a site, you take your maximum concentrations, you use the worst case scenario and calculate what is the risk for people, children, pregnant mother, a daycare center, or for a wetland. You just calculate what is the risk using the worst case scenarios, using the site concentrations, exposure factors, and gives you a risk. The backward mode of risk assessment, which we now routinely call as screening levels, PRGs, regional screening levels. EPA has a regional screening level. This is the backward mode of risk assessment. Government gives you the target risk. They set you with 1 extra cancer in a million or 10 extra cancer in a million. Then you calculate backwards and say, this is what can be left in place. The forward mode of risk assessment and backward mode of risk assessment are key part of the risk-based process. Thank you. Next one. So here is the master equation for forward mode of risk assessment and backward mode of risk assessment. In the forward mode of risk assessment, you calculate what is the site data, or you can go to the field and collect the data, or you can do some modeling and collect the data. Then you multiply that with exposure factors, toxicity factors, and then you get the risk. So in backward mode, the risk is given to you, toxicity is given by US EPA, exposure factors are either default or site-specific. Then there are chemical-specific factors if you are doing fed and transport, and media-specific parameters if you are doing fed and transport, and gives you the compliance point concentrations. Next slide, please. So risk management follows risk assessment and used to decide whether calculated risk is acceptable. If the calculated risk is not acceptable, develop cleanup levels, remediate sites to cleanup levels, or use institutional controls to manage risk. So risk management includes technical and non-technical considerations such as policy choices, cost, stakeholder agreement, risk perception, institutional controls, and long-term management of risk. Risk management has, you can do engineering control, pump and treat, soil vapor extraction, biodegradation, land use controls, engineered controls. Nowadays for vapor intrusion, everybody is using subslab depressurization systems, an HTP layer, barrier systems, some examples of engineering controls to prevent vapors coming into the building. Institutional controls are an important risk management tool, allows productive and safe use of the property, ensures that the assumptions used in the risk assessment remain valid, knowledge of impacted sites is not lost, provided in California we have a geo-tracker system. Once it is there, this knowledge is not lost, provides long-term protection for risk-based remedies. But it's important that institutional controls have to be tracked and followed also for them to be alive. Good examples are what happened in Love Canal. They put deed restrictions, nobody followed it, and then you know what happened after that. Next slide, please. So fundamental paradigm shift. Conventional approach, how much chemical mass can be removed? That was when I started working as a regulator, that was my goal. How much can you remove? In the risk-based approach, how much chemical mass can we safely leave behind? I know it's a very uncomfortable statement for many regulators and citizens, but because we cannot remove everything to pristine levels, we ask the question, how much chemical mass can we safely leave behind? And we use risk assessment that is the best technical tool that we have to answer that question. How do we ensure that future generations are aware of the chemical left behind so that there are no surprises? There are several systems available in California. We have a very good system GeoTracker that you can go and track, but there are other systems available also to make sure that these informations are not lost. Next slide, please. So, summary, the key aspects of risk-based decision making. The site conceptual exposure scenario, once you develop that with PRPs, stakeholders, everybody, it establishes a good framework for your future work. Because every PRP, every one wants very, don't want to spend unnecessary time and work. Everybody wants to see the light in the end of the tunnel. So it establishes a good framework. The quantitative target levels, the risk assessment, tier 1, tier 2 risk assessment establishes measurable goals for somebody. If I'm spending the money, I need to know, I have to have goals, established goals to release my money to go and do the work and all. So the quantitative target level allows that. Tiered approach ensures efficient use of resources. Upfront involvement of the concerned parties brings acceptability. So risk-based approach gives you these 4 good uses for anyone to use this methodology and get some results in the end. So these were the things that we covered last time in our basic approach. So this is an introduction to those who did not attend last time. And what's the next slide? So summary of Rebecca is a process. So Rebecca is not like a thing. It's not a formula. It's not an equation. It's a process. Site assessment, risk management, involvement of the stakeholders all together. Many people think that Rebecca is like a toolbox. You go and fix something in your toolbox, an equation, and you have an answer. No, it's a process. And again, the state has to give you very clear regulatory requirements how to move this process from site assessment to risk management. The outcome, identification of need for an extent of risk management. Identification of need for an extent of risk management. How much risk management we need to implement at the site. The benefit, if implemented and documented correctly, should provide a finality to site activities. The main reason that the California slow thread policy came was state wanted a finality for all these sites. There were so many different agencies implementing it. The people of the state were complaining there is no finality for these sites. So risk-based approach gives you a finality for the site. That's all for my introductory slides, everybody. And at this time, the way we are planning to continue or planning to conduct this workshop is we have come up with about 10 or 15 questions, common questions that people encounter in trying to implement risk-based decision making. Some states don't have a well-written policy like California. Some states follow a general ASTM approach. Some states within that have created their own programs. So we have 3 very experienced people in this in the panel who are going to share their experience, how they are handling these sticky questions that we have come up with so that you can learn from their experiences. And I'm going to ask Matt first, and then Hannah second, and Laura third, how they are going to, let's see what the answers they are going to give from their experience. The first question is, how do you reconcile risk-based closure with water quality objectives? And let me bring some context to this one, because states are different. Every state has a very stringent benzene number. California is 1 ppb, rest of the state is 5 ppb. And you just heard a little while ago in the Rebecca paradigm shift, it's not cleaning to pristine. How much mass can we leave there? So you're obviously leaving more than 1 ppb benzene and 5 ppb benzene all over California. So how do you reconcile when your state says you have to clean it to 1 ppb and 5 ppb? Risk-based decision-making says you have to clean it to, in California, Matt Cohen leaves up to 3,000 ppb benzene and he closes the site. So how is this reconcilable, and how is each state handling this very important philosophical question? You're supposed to clean it to MCL, but your risk-based approach, risk assessment gives you a different number. That's my question. Matt, you go first.
So in California, we water quality objectives are actually the goal. And when the policy was developed, it was started with the understanding that petroleum naturally degrades in the environment, and that typically the UST sites, typically the releases are shallow. They tend to stay pretty well on site. Generally, plumes are less than 1,000 feet long. And so given those two things, the concept is that we want to reach water quality objectives before someone is going to use that water. One of the main general criteria of our low-threat closure policy is that these sites be within the service area of a public water system. And so that ensures that we don't have shallow domestic wells. And so the idea is that this shallow groundwater that's relatively close to the point of release generally isn't going to be used for a long time. And so the concept is we will reach water quality objectives within a reasonable time frame, and our precedential orders have sort of defined that reasonable time frame as decades to hundreds of years. And that's, we expect that shallow groundwater won't be used within that time frame.
Matt, do you have any special provisions in your California that you can't use the shallow water?
There are not.
So anybody can use the shallow water if they want?
Well, so when installing drinking water wells or installing wells, California requires there be a 50-foot sanitary seal, and so indirectly, people are prohibited from using that groundwater.
Good, thank you.
And it's the same groundwater that we permit septic tank discharges, and so we sort of, there's an understanding that groundwater isn't going to be used.
Hannah, it's your turn.
Hi, Ravi. A lot of what Colorado, their guidelines are pretty similar to California in the expectations of the use of the groundwater. If there is going to be a risk-based closure, then the goal is to make sure that water quality objective is met at the point of use. And to do that, Colorado uses some things to help support that decision. A water well surface water receptor survey would be completed. We would use state and transport modeling to support that point of use wouldn't be impacted or threatened. And then points of compliance are also something that's used to help support that.
So you allow very sophisticated pay and transport model. If somebody comes with a very sophisticated pay and transport model to show that this plume is not going to reach the point of exposure, you accept all of that.
Correct. It would be a combination of all of those things and possibly something else depending on the specific site, but that would definitely be one of the criteria used to support that.
So who chooses what kind of pay and transport model to use? Do you recommend something, or do you advise something that you preferred methodologies?
Well, the state of Colorado uses BP risk modeling, which I think actually it's just risk modeling software, but you can use, there's a lot of different types of software on the market for freight and transport modeling. And as long as we can replicate the data, the output from that model, then we would support it.
Good. Laura, you are next.
So my Missouri is very similar to Colorado and California, and we do evaluate the pathway, and that the water quality objectives are definitely important here in Missouri because we do utilize the groundwater for drinking water in most of the state. Not all of it, but most of it. We also here not only evaluate current pathways, but future pathways. We do not rely as much on the urban zoning. We recently got a new law that kind of makes it so that's less of a value when evaluations come through. But we do look at the concept as an area-wide, not property-by-property situation. We look at the whole area for whether or not it's currently being used, definitely privately within a quarter mile, publicly within a mile, because we do have some areas that we have had large distances spanned between source and wells that have been impacted.
Before we go to the next question, I have a question for all three of you on the same topic. Can you share with the audience, how long does it take to close a site in California, in Colorado, in Missouri, an average gas station, not one of these on the right-hand side of the bell-shaped curve, just an average site. If you have to reach water quality objectives and you are using risk-based approaches, what is the average time frame to close a site? Matt?
I think that that's a challenging question in California because our low threat closure policy wasn't adopted until 2012. And really our leak prevention group has effectively stopped any new releases. And so when we look at the age of case at the time of closure, most of our cases are 30 years or more old. And so our low threat closure policy is really a tool to attack a legacy problem and not a current problem.
Good. Hannah?
I would agree with Matt. We have definitely used this to address a lot of legacy sites. It will continue to be used as sites are continued to be opened, but as far as an average time, I mean, it can vary from 5 to what Matt was saying is 30 years, depending on the site specifics.
I think in an ideal world, if there were a new release and the responsible party was on top of it, using the tools, developing a project plan in order achieve closure and using the policy, I think 5 years is a realistic expectation. But again, we just don't see those.
I'm surprised because my sites those days took 17 to 20 years, but good. Laura?
I'm in agreement with the others. I mean, like new releases, you get right on them, you can get them done real quick, 2 to 5 years, even with going to drinking water targets. But when you don't find out about the site for 20 years because you don't find it until closure, or the sites that have been around since before in Rebecca, they're already in there 20 plus years. And the plume is huge. It's the products all down in the pore spaces and just constantly leaching out. Very difficult. So it takes some very unique, sometimes out-of-the-box concepts to get some of these closed, and it takes time.
Good, thank you. It was a surprise question, but you guys all tackled it very well. Next question is for the panel is again a sticky question. How do you define a stable plume? Every regulation in the country talks about the plume as stabilized. The site is by remediation, you have exhausted the site contamination. The dragon's head has been cut, or you can use, it's a dying plume. It's not, it's a stable plume. But how do you really define a stable plume? I like to hear the nuts and bolts each state is using to make sure that the plume is stable once the tank has been removed and there is no continuous source coming into the site. Matt, you can go first.
So our policy supporting documents define a stable plume as when the contaminant mass has expanded to its maximum extent. So the distance from the release where attenuation exceeds migration. And so what that means is it's not continuing to grow, that natural attenuation is working faster than migration. And so
you're saying spatially it's not migrating?
Spatially. And so typically we demonstrate this with a network of monitoring wells with some period of time where you show the distal edge of the plume either decreasing or staying stable. And what's sort of important to note, and maybe is a sticking point in California, is that it's not necessarily that a well within the plume doesn't go up or down. You know, we often, within a stable plume, we'll often see internal wells go up and down as things move and change, or even just sampling techniques. But that in aerial extent, that plume is not continuing to migrate. Important part.
You said some time frame. How many years you monitor?
We don't have a specific set of years, and that can be a point of contention. That how long? I think that typically our regulators are looking for a year. Some are looking for more. Some are looking for less.
Do you have big fluctuations in groundwater table in California?
Yes.
So
which can affect, you'll get remobilization of NAPL, and you'll see that wells near the source may increase or may fluctuate, but as long as the distal edge of the plume is not increasing, not continuing to migrate, then we consider that a stable plume.
Some sites don't have enough wells. They are so tiny, there's not enough wells to really put your arms around the plume. And what do you do in those kind of cases?
Those tend to be challenging. California has sort of a unique regulatory structure that we have 9 regional boards and 10 local agencies that implement these cases, and we at the state board are sort of the oversight of that. And so we often sort of get in the middle of the disputes between regulators and RPs, and so we see this a lot where, we have to balance whether additional data is needed, whether we can interpret the size of the plume based on the data we have. It's really site specific. It can be challenging, yes.
But do you agree with me that this is one of the most important yardstick before determining a site is a low threat?
Having a good site conceptual model is extremely important to making these decisions.
Good. Hannah?
I would agree with Matt as well. Colorado looks at, the migration of the plume. If it's reached its spatially the area that it's going to cover, and if biodegradation is occurring faster than it's continuing to migrate. We look for contaminant concentrations and whether they're decreasing or staying relatively stable. Again, we look for over a time period to address or to adjust according to seasonal fluctuations. We kind of like to see it stay within an order of magnitude, but it also depends on the site. If you have huge fluctuations in groundwater, I think in Colorado we can see 5 to 10 feet to 20-foot fluctuations, and those would be addressed a little differently than some of the other ones that don't really have a large fluctuation in groundwater. But yeah, very similar.
So do you use any statistical programs to make sure that these wells, the up and down is significant or non-significant, and how long? You said we also monitor for some time period. I'm trying to nail three of you. How long do you monitor this to make sure it's a stable plume? And Matt has escaped answering that, and I want the other two to see whether the audience like to know how long I had to measure before I know it is a stable plume. Do you use any statistical approach?
We don't use any statistical approach. It's more of historic data, and just establishing that. Again, what Matt was saying with the conceptual site model, the more thorough that is, the more it can support that plume is stable. And then as far as the amount of time, it depends on the site. Again, if it's a more complex site, if you have more fluctuations, you may be required to monitor this for a longer period of time. I know that we like to see at least 4 quarters of data showing that there hasn't been seasonal fluctuations exceeding whatever limits we're trying to get to.
Good. And if I come to you with a site of 4 quarters of monitoring for 2 years, is that would be, and there is no statistical significant changes to those numbers, would you accept that the plume is a stable plume?
Possibly.
Thank you.
I think that to maybe better answer your question, I think that it again comes back to the legacy issue that we really don't see cases that don't have 20 to 30 years of monitoring. And so to say how long, we've been monitoring these sites forever, and so we don't generally run into that question.
Tara, everybody is waiting to get some good answers from you.
Okay, a stable plume in Missouri is one that can be statistically shown to be stable or decreasing over a period of 1 to 2 years monitored on a quarterly basis. Typical statistical methods are the Mann-Kendall or Joe Ricker's method for overall plume stability. Is that good?
Very good. And what happens, I missed one quarter. Will you forgive me?
It depends. Again, as the others have talked about, the site conceptual model, if you've got a complete domestic use pathway, if people are drinking that water, no, forgiving it doesn't really happen very well. But if we're talking about vapor intrusion, yeah, probably.
Okay, good. So to the audience, these first two questions are very important questions. Only your state can give you some good answers to these questions. Rebecca, neither the ASTM Rebecca standard doesn't give you answers to these questions. You got to push your state regulators, your management, to come up with some good policy answers for these first two questions. Okay, let's go to the third one. Third one is a long-winded question. Let me also give a background to that. It says, what do you consider a secondary source, and how do you know when you have removed secondary sources to the extent practicable? My intent was to challenge the audience or the panelists on what is extent practicable, and my use of secondary source is this way. When the tank is removed, which is contributing to the ongoing leak, the primary source is removed. So the tank and the leak were the primary source. Once that is gone, there is no new mass is added to the area where the tank was. So it is the contamination in the vadose zone, however deep the vadose zone is, and the groundwater plume that has formed, collectively called secondary sources. And then the question is, everybody wants to know how much to remove, and in some areas very hard to remove. Some areas backhoe cannot go more than 30 feet. Some areas there's no way to do shoring because they are surrounded by buildings. So this question is, because California has do what is practicable, do extend to the extent practicable, and I want to see how each state is using reasonableness and what kind of qualitative ways you are using the extent practicable to be defined. That's the intent of this question, and I'll go to Matt first.
And so in California, secondary source has a more specific definition. That secondary source, our policy defines secondary source as the impacted soil and groundwater immediately beneath the point of release. And so we're immediately is sort of a vague term which can be sticky for our state. But in general, we're talking about the soil and groundwater right underneath the tank that you could maybe readily get with a backhoe or pumping when you remove the tank. We're not talking about in the vadose zone that's 50 feet deep. So to us, secondary source is a very specific, very shallow sort of.
And what is extent practicable? What is extent practicable?
And so extent practicable, again, is one of those sticky terms. It's fairly generic, but basically we want to weigh, okay, we're looking at the risk. Is there a risk from what's remaining? What are the cost and environmental cost of remediating those impacts, and we have to balance that. We have to weigh, what are we protecting, who are we protecting, and how much is it going to cost to do that, and are those resources better used on a site that has a greater risk, or do we need to solve the risk here and protect whatever the exposure is?
So one could argue that digging that and transporting to a landfill will cause more carbon footprint than leaving it and managing it, because it's not going to cause any further degradation to the groundwater, and it's going to be managed. You could argue that.
Correct.
Okay, good. Hannah?
We don't refer to a specific secondary source. Our risk-based closure criteria does require contaminant removal to the maximum extent practicable, or MEP is what we call it. And the definition of practicable is able to be done or put into practice successfully. So what's practicable for one project may not be for another. We look at hydrogeology, geology, the depths to those, to the groundwater. What you were saying with excavation kind of depends on the depth that you would want to dig to, the cost-benefit analysis of that, property use, if we can get access based on structures or private properties. All of that's taken into consideration if we determine if they've met MEP or not.
So primarily a determination by the regulator?
It is, yeah.
Okay. Laura?
In Missouri, we don't use extent practicable unless we're talking about free product recovery. When it comes to just meeting risk-based target levels, you meet risk-based target levels or you otherwise manage the risk. There isn't a give on that to say that there's an extent practicable. We don't consider costs. You either meet it or you don't. Extent practicable, like I said, is used for recovery of free product. And in that situation, we use corrective action guidance, corrective action plans, very site-specific on what we've got to do to meet there. And we use the technical ability of what's appropriate for the site, a lot of what's talked about in LNAPL 3 and the ITRC document. Make sense?
Very good. When you say meet the target levels are either calculated or given by your state.
We have risk-based target levels that are in the guidance for our Tier 1 level. At Tier 2, you get to do site-specific, and then Tier 3 is open to allowing other models. So we're very flexible.
Okay, so you follow pretty much the ASTM 1739 guidance. Very good. We'll take two more questions and then we'll open for some questions from the audience, but let me go to the next one.
Yeah, and just to interject real quick, Robbie, this is Drew. Friendly reminder to everyone listening, if you hover your mouse, bottom of the screen, you'll see that chat bubble. That's what you'll use to ask any related questions or piggyback questions following up on what the panel or Robbie are saying. So please, I don't have any yet, but feel free to send them my way. And as Robbie said, in a couple questions, we'll break for Q&A. So go ahead, Robbie. Thanks.
Yeah. Audience, this is your chance to challenge the regulators. So give your questions to Drew and we will collect them. And the next question I have for the panelists is, how do you close cases with free product? Some may not even allow sites to be closed with free product. I think California allows in very specific situations to close cases with free product. I would like generally, if your state does not allow, I would like to hear from you. What do you guys do with sites with a persistent free product? It appearing in one well like 3 millimeters thick, and next quarter it is 3 centimeters thick, and persistently appearing. What do you guys do under your program? That's my question. Pat?
So in California, we separate LNAPL. We separate the NAPL into the mobile fraction and the immobile fraction, and we define free product as the mobile fraction. And so we have a criteria in our policy that allows us to close cases where free product or the mobile NAPL has been removed to the maximum extent practicable. Again, that sort of generic term or vague term. Generally, our regulators are given the option to put a deed restriction or deed notification on the site that's closed, so that it's very clear to any new owners or any new occupants that this free product still exists. And generally we look for that it's stable, kind of sort of similar definitions of how we're defining a stable plume, and that it's not contributing to increasing dissolved concentrations, that really it's not moving, it's just sort of sitting there.
Matt, I have two questions for you. Can you put a little more meat into when you said we try the maximum extent practicable? Can you help us? Well, we have been having a SOX there for the last 6 months or 6 years. That's all it comes there. It appears, disappears, and the thickness has changed. Give me some little more meat when you say the floating product has been removed to the extent practicable.
So in general, I think that this is one area that isn't always applied consistently throughout California. Some regions where groundwater is not used as frequently, they're more apt to close cases with free product. Other regions, they'll continue as long as it's there. They'll continue to ask you to do it. And so, at the state board, when we look at reviewing cases, we look at, are we making a difference? Is the remediation, is the remedy that we're doing making a difference? And what are the impacts what are the negative impacts of leaving that free product? And it's really a balance of those two. I think that we often see putting SOX in or doing manual extractions over and over and over again, and they'll pull some free product out. It doesn't recharge until the next time they go sample, and they're really not making a significant difference, and they're spending a lot of money to resolve it. And if there's no risk associated with leaving that product in place, then push for that.
But if that particular well that is appearing, that floating product, is very close to a property boundary, and you suspect the floating product has crossed the property boundary, will you still close it?
No, that's one of our the free product has to remain on site.
I see. And what percentage of sites that you close in California has one well or two wells that are floating product?
It's pretty low. I think that our regulators tend to be conservative on this issue. I would say less than 5%.
Less than 5%. Good answer.
I mean, that's a ballpark. Don't go look at the data and tell me I'm wrong.
So, Hannah, do you close sites with floating product in Colorado?
We do.
Yeah.
We evaluate its recoverability and how the LNAPL affects the groundwater composition and vapor exposure pathways. Recoverability is determined by the transmissivity value, and there's been some research done on value ranging from 0.1 to 0.8 square feet per day, and if you can complete that calculation and show that it's below that range, then we determine that it's not economically or physically feasible to remove it. And we focus more on the dissolved phase and vapor phase of it and the risk that those pose instead.
Very impressive, because you guys are using actual science in determining that one. Many states don't allow use of these technical values in determining whether it is the free product is going to can be extracted or not. Good. Laura?
When it comes to free product, we look at a lot of what's been done by ITRC. Having been on the work group, we don't allow the use of SOX. SOX are for feet, not for recovery. We do have kind of two paths to go down when it comes to free product. One is for your sites you keep talking about with the 3 millimeters or quarter of an inch or whatever you want to call it left in the well. Old legacy sites that just have this eternal 1 or 2 wells that have free product in them. Those sites, we require an LCSM, LNAPL conceptual site model to be completed. And based on that, we evaluate whether or not qualitatively there's a need for any active recovery. Generally, if they're on the edge of the property, under a road, things like that, where they just stop digging because the road would collapse, and we don't show that it's on the other side of the road, we're going to close those kinds of sites if there's just a minor amount, as long as there isn't a risk associated with that free product also. We do evaluate risk to construction workers from free product, and also vapor intrusion and, of course, domestic use. With newer releases, we definitely go into the path of using the ITRC document, what's the best methodology for recovering free product on that site specifically, and have they tried it? If there's a method that's usable, what happens when you actually try it? If there's recovery that's possible, we expect them to recover to the extent of that methodology at a minimum, but again, they cannot have a risk associated with anything remaining. We do consider transmissivity, but it's only one line of evidence in our path. It's not the be-all, end-all, because there are other methodologies that don't rely on transmissivity. Phase change, et cetera, transmissivity is not relevant.
And you said that there shouldn't be any risk earlier. How do you have a way to calculate the risk from floating product?
Well, we use the a default value for fresh product, or else we require them to go have the product analyzed in laboratories. If we're doing dermal contact, we use a standard groundwater sampling analyses and use the same groundwater targets for dermal contact. For indoor inhalation, we use vapor intrusion targets.
I see. Who provides you all this? Your state provides you with these technical documents for you to evaluate, or you use ITRC and other EPA documents?
We mainly use ITRC.
Okay.
But we are open to any peer-reviewed document. If somebody wants to come in with some new technology to take into consideration, we'll be happy to review it.
Okay.
We don't limit the technologies except based on their own merits. And that's all corrective action and all part of the corrective action plan.
Let me take one more question before we invite the audience to ask questions. Next question is, how do you close cases with off-site impacts? Because gas stations are small, postage size. Sometimes the release can go very often into next to commercial buildings, next to a car wash, sometimes into restaurants, into neighborhoods. So how do you close cases when you have off-site impacts? What do you require from a PRP to be in compliance with your policy?
So in California, the criteria in our policy can generally be applied to on-site and off-site properties. And so the expectation is that when the PRP is looking at closure, that they evaluate wherever the plume is, whether it be on-site or off-site, they evaluate it using the policy criteria and determine if there's any risk associated with exposure at that off-site property. I think as a general rule, our regulators are more cautious with off-site properties. I think we sometimes hear concerns about devaluation of off-site properties or redevelopment of off-site properties. Those issues, the devaluation thing, we don't really see come up. We do sometimes see problems with redevelopment, and when there's redevelopment at an off-site property, either the case has to be reopened or they have to go back to the RP, and the RP is responsible for any additional remediation.
Isn't redevelopment is a business decision between two people? Why are you involved with the redevelopment? Because if I'm buying the property that has off-site contamination, I'm negotiating a price with the person who is selling. It's a business decision.
I think I think it's set up in that way, but as a general rule, our regulators will reopen sites as needed to address remaining issues.
Even after the site is closed under your policy, it meets all the yardsticks, you still reopen it because somebody's site is going to...
If there's a change in land use...
A change in land use.
Then there may need to be some reevaluation.
If the land use is commercial to commercial, you won't...
There's generally not an issue. I think, sometimes we'll get where, there's a above grade construction, and then the redevelopment includes some kind of subterranean something that sometimes will cause reevaluation.
So your policy in and of itself treats on-site, off-site as the same. Correct. As long as all the criteria are met.
Correct.
If it is an off-site plume, does the regulators have to do special notifications or something like that?
So our policy has specific notification requirements. We notify the current property owner and occupant, any impacted property owner and occupant, and any neighboring property owner and occupant. So everybody should get... And
if they complain, do you go and ask?
If they complain, we evaluate their concerns and determine if they raise valid concerns. What we find is that, I think our state board has closed on the order of 500 or 600 cases since our policy was adopted, and I think I could probably count on one hand the number of times that neighboring property owners have submitted comments. It's typically when we get comments, it comes from some other agency. It comes from a water district or another cleanup agency.
Hannah, it's you next. Are you there, Hannah?
Sorry about that. We do allow off-site impacts to remain in place with risk-based closures. We have 2 of those that address off-site impacts. One of them, impacts can remain beneath a roadway, and then the Tier 4 closures, we allow impacts to remain in place on an off-site property regardless of the land use. But ultimately, if they meet that closure criteria, we are just evaluating the exposure pathways and the risk. And if those can be eliminated, then we will pursue that closure regardless of if there's off-site impacts. Again, the conceptual site model is very important. If there's going to be off-site impacts, we want to make sure that it's thorough and there isn't any questions during that closure.
What I'm hearing from you, Hannah, from the previous answers, looks like Colorado has a very, very prescriptive, very well roadmap for people to come and implement risk-based, and it's easy to implement because it's the path is pretty clear, and you guys implement a very strict a textbook kind of risk-based approach. Am I correct in summarizing that?
Yeah, I would say so. I mean, we pretty much are most concerned with risk and closing, vapor, groundwater, soil pathways, and as long as those can be evaluated thoroughly and eliminated, then a risk-based closure is definitely can be pursued.
I would say California is also a risk-based approach, but in California, because there were so many agencies that were there were so many kingdoms and tribes doing UST programs. They needed some consistency. So they, in addition to a risk-based approach, they also gave risk-based target levels and numbers, plume lengths, concentrations, soil numbers, vapor numbers, all for people so that there will be consistency throughout the Golden State. Good. Laura, next.
Well, evaluating offsite properties is just part of our process. Current and future use for all impacted properties has to be evaluated in the risk assessment. And as far as change in use by the neighboring property owner, if the risk assessment assumptions are changed, then the risk assessment has to be reevaluated. So we would reopen a case if we felt that a property was evaluated, say, for a non-residential use and someone came in and put a residence on there, we would reopen and require a reevaluation at a minimum.
Good. So we have tackled some very sticky questions so far. We have 5 questions. We are a lot of technical things. I would like to open up the stage for any audience to ask any questions at the panel members. Drew, you have any questions?
Yeah, so I'm putting up a couple right now on the screen. I got a couple of good ones, and they're a little bit longer, so I thought it would make sense to project them. Do you guys see that?
Okay, let me read that, and then I'll again each Matt and Hannah and Laura can take a stab at it. First question is, any states accepting remediation off-site or remediation offset? Example, wetland restoration, support for desalination plants or community redevelopment projects as alternative to more remediation that may be more detrimental to environment. How much is commonly brought into the ultimate decision-making around closure? Very nice question. I like it because we are all concerned about climate change and carbon footprint. And many of the times, the amount of digging I have done in my life, just for the sake of digging and cleaning and sending it to the landfill, the amount of tractor diesel, in my 10 years of a regulator, and the carbon footprint I created in relation to risk is a crime. So this is a very good question. I like to see whether your programs allow this kind of nexus, because in EPA, there should be a nexus to the activity for your underground storage tank and a wetland. Your wetland can't be so far away in a different community. The laws in California won't allow you to take this money from this project to that project. There should be a nexus. That wetland should be right next to the gas station is going to benefit, or the community is going to benefit. So let's see how the panelists are going to tackle this one.
Well, and in California, in the underground storage tank program, we don't have this offset. I've never seen any kind of offset used. I know that our Department of Fish and Wildlife uses a similar concept. That if you're going to take habitat or species, then you have to do some kind of offset somewhere else. You have to provide habitat somewhere else at a 1 to some rate 1 to 10 or whatever it is. But this is not a concept we've addressed at all in our underground storage tank program.
But if I come to you, will you entertain me?
I don't know if we even have. I wouldn't know if we have the. Sure, I guess I would, because we would let you close a low threat site anyway. And so if you're going to say, I'm going to close this low threat site and I'm going to do some kind of offset, then sure, I'm going to let you go do your offset. But we don't have that. We don't have that regulatory structure for our underground storage tank program.
But if it is a bulk terminal, I can, maybe this is useful. It is also petroleum, which is a larger, right next to a canal, but you don't.
Well, and when you're talking about bulk terminals, you're sort of outside of the underground storage tank cleanup world and really kind of outside of our low threat.
Maybe this is something your state should start evolving into.
I think that, the next frontier for California is site cleanup, sort of all of the other kinds of cleanups, and I think that this would be an interesting concept.
Hannah, any wisdom words?
Same, kind of along the same lines. I don't know. Again, we would look at the risk for that specific site. So if it's threatening human health and the environment, then we would require some type of remediation or continued monitoring, regardless of a remediation offset. But if it was a low risk, and two, underground storage tanks are usually, generally in higher populated areas where there isn't such a low risk that's way out in the. I think remediation offsets are normally used for areas that aren't high population, it seems like. But if it was, again, like Matt said, if it was low risk to begin with, we would look to try to close it as such, regardless of whether a remediation offset was going to be completed or not.
I think this question is more, there is a gas station, has some floating product, it's just sitting there and it's not going anywhere, and it's hard to get it out. In that case, can you do some kind of an offset? Only when you cannot reach the low threat level policy or low threat yardsticks, then only somebody will think about, okay, I'm wasting so much time and so much money. Can I do something else? That's right.
Well, and I think that we just don't have the regulatory structure. We don't have statutes or regulations that allow us to do that.
Laura?
I agree with what's already been said. What I can say is, during the economic stimulus or ARA projects that we had, we did take the sites and turn them into some community gardens, but that was really the site itself. There wasn't any sort of, I'm not going to clean up this one, but I'm going to clean up over here or do something over here. That's taking one area and allowing it to remain contaminated while another one is getting cleaned up. I don't think that would go over real well here, and I haven't seen any regulatory change pending that would indicate that. As Hannah said, gas stations are on those key corners, and a lot of what's driving that cleanup is redevelopment, the bank loans, things like that. I don't see them cleaning up a wetland instead of cleaning up that corner.
Agree. Good. This is this mitigation project always comes in discussions, and it has to be state-specific answers to that. The next question is probably more towards Hannah, because you guys are the one who use and transmissivity, and if you read the ITRC document, and if you ask 5 different consultant geologists to calculate transmissivity, they will come up with 5 different numbers for the same site. So I was going to ask that earlier, but I didn't want to challenge too much, and somebody is asking the question. So how do you just buy what the contractor says, or do you go and do a rigorous peer review of their work? Because transmissivity calculation between 0.1 to 0.8 feet per day is almost like a snake oil. Sometimes can be a calculation like diesel will degrade to MCL in 32.8 years, something like that. So Hannah, can you first give your sense on that?
Well, they would have to provide the information that they collected, the data they collected. We have the API worksheet that we like to see, and that requires a little bit of input to come up with that value. It's a range. So if they're very far from that range, you can kind of get an idea of if product is recoverable also by how fast it's coming back into your monitoring well. visually just by looking at the data, that value just kind of gives you a line of evidence to tighten that up, to have some supporting actual data for it. So I think there would definitely be some scrutiny on the regulator side, especially if it's very close to that range. We'd also look over the data itself and see if we think they weren't doing it correctly, or maybe they need to reevaluate and recalculate. It can also change as the site progresses towards remediation, which we might request them to complete the test again.
Hey, Drew, before we move on, how many more minutes we have?
We have about a half an hour. Yeah, I just threw up kind of a follow-up to that first question, but yeah, about a half hour as planned.
Okay, so I would like to dedicate the next half an hour quickly to some more sticky question to the panel, and then see whether we can at least tackle 3 more questions. Okay?
Yeah, so that sounds good. I'm going to hand off the controls back to you guys.
Okay. So my next question is to the panel is, how do you close cases that are also impacted by non-petroleum constituents? Let's say your site has is similar to, I'm going to combine 6 and 7 together. You have a commingled plume. You have a gas station plume. It has had a waste oil tank, and they had some solvents. So you have a commingled plume in your site. How do you handle that one?
So in California, we have separate cleanup programs. There's different regulations and statutes that dictate what we do in the underground storage tank program, and then our other program is called the site cleanup program, and it's sort of brownfields or basically anything that's not an underground storage tank. I think that the typical scenario we see with other constituents is, as you said, as you mentioned, the waste oil tank. So non-petroleum constituents released from underground storage tanks can be cleaned up in our underground storage tank program if they're de minimis. And so de minimis is defined as the other constituents don't significantly alter the detectability, the effectiveness of corrective action, or the toxicity of petroleum. So basically, if those non-petroleum constituents are driving the risk, they have to be carved out and cleaned up under our other program. And really, it's a resource thing. So in our underground storage tank cleanup program, we have a cleanup fund, and it funds site work, it funds our regulatory oversight of the program. And so it's inappropriate to use those funds based on the way that they were developed. It's inappropriate to use those funds for non-petroleum constituents. When we evaluate those sites, when we evaluate a site where there is a non-petroleum risk driver, we look at the petroleum. Typically, we look at it separately. So if the petroleum constituents don't pose a risk, then we'll close the petroleum constituents and then continue on with the non-petroleum constituents. There are some cases where regional boards are looking at what are the combined the total risk. So and particularly, I think we're talking about vapor intrusion. So we push our regulators to evaluate a risk to occupants of buildings from the petroleum constituents using the concepts that are in our policy. So, we talk about setback distances, things like that. And so we evaluate petroleum under those, that framework, and then the non-petroleum constituents. If we're talking about vapor intrusion, we're using EPA VI guidance with the 0.03 attenuation factor and all that. And so then you can add those two together and come up with a total risk.
2 different caseworkers will come and handle it, or you first do it?
It depends on some regions. So some of our agencies have separate programs and some are combined. And so in those combined regions, oftentimes same caseworker, but different cases, and you know, it kind of changes how they have to bill for the project. But some, again, like you say, some regions have two separate caseworkers looking at it, and that can become challenging because it's two different kind of ways of looking at evaluating risk.
Hannah?
The division, so I work for the Division of Oil and Public Safety, and they regulate only underground storage tanks, petroleum constituents. If we are working with some type of non-petroleum constituent, then that would be regulated by the Colorado Department of Human Health and Environment. So if there was a commingled plume in that regards, in general, we would probably have some type of agreement with them, and it would be a joint thing. But generally speaking, if it's a non-petroleum constituent, then they would be the one to remediate that.
What about waste oil tanks?
Waste oil, we would work with them. If it's a petroleum constituent, then we would work with the remediation for it. If it's not, I guess sometimes for some reason PCE would get dumped down those sometimes, and so in cases like that, then CDPHE would come in.
Laura?
Here at Missouri DNR and our DEQ, all the cleanup is under one program. So our brownfields, our federal facilities, Superfund, and tanks we're all together. So we do have a few sites where, especially Superfund or federal facilities, have had tanks. And of course, Superfund can't handle petroleum really very well. So it's really site specific. We work with the other program. We figure out who has the priority, who has what laws, and which is most appropriate to go forward. Most of the time on Superfund sites, their issues are much bigger than our tank issues, and we would let them take the lead and they would include in their work petroleum analyses, and we would assist along the way. We have split a site with the Brownfields group. They took one side of the property, we took the other side of the property because of laws that made it so neither one of us could handle it altogether. And it was, but again, it was just an agreement. It was made with the RPs and fully informed of the what and the why, and we've been real successful at just parceling it that way.
Interesting. Every state has very unique way they are handling this. Go ahead, truly. Matt, I want to go to, in the interest of time, can you go to question number 10? Because here is a very important question, because risk management comes with managing risk. You're leaving, you're not cleaning it to pristine, you are leaving some chemicals, then how do you manage this into the long term? That is a perennial question. When risk-based decision making came in the early 90s, this was, I don't think we still have a very good answer to this one, because US EPA has been trying to come up with some kind of a master program for all the states. How do you manage institutional controls in the future, and how are future owners informed? And Matt?
So in California, we have the GeoTracker database, and all of the project reports, all of the site data after 2005 is uploaded to our database. It lives there indefinitely, and any prospective buyer or occupant of the property can go and they can look and see what's there, what was done, what was left behind. And so that is kind of our first line. You know, when we talk about institutional controls, typically we're talking about free product and vapor intrusion. Free product, our policy has, I think I mentioned before, our policy has the ability to add a deed restriction, and so that's sort of an extra level of protection for future property owners. But then where I think where it gets more vague and is vapor intrusion and what can be allowed, what's acceptable. We don't have a specific guidance, or we don't have the ability to sort of consistently apply application of mitigation measures. So when we talk about vapor barriers or passive or active mitigation, how much do you monitor? Do you monitor? Those kinds of questions. We don't have answers for those, and we're sort of looking to ITRC. I think is developing a guidance or a training right now on managing mitigation or institutional controls, and so I don't have great answers in California.
Yeah, you mentioned the word GeoTracker. Can you tell the audience what GeoTracker is?
So GeoTracker is a spatial database.
Who owns it?
So California owns it. It's managed by an outside contractor, but it's
paid by the state of California.
Paid by the state of California.
Okay. And it's a spatial. What did you say?
So it's a GIS. It's based on a Google platform, and so essentially members of the public can go to our geotracker.waterboards.ca.gov. They can search the map. They can look around their house. They can see all the different sites or all the things that are near them. Once they find a site that they want to look at, they can drill down and look at all the reports. We collect electronic data, locational data for wells, things like that. So.
And does the deed restrictions also posted in the GeoTracker?
Not as consistently as they should be. So we have places to put that, but it's not consistently applied by our regulators.
And so this is going to be eternally alive, and this is going to be
that's the intent. Yes. I mean,
and the legislature pays for this. For this system.
Our underground source tank cleanup fund pays for it.
And how much is the system cost to? Because other states may want to create something like that.
It's a lot.
A lot of money.
I think we manage it. It's a software as a service, and so it's not just used for our underground source tank program. It's used for our site cleanup, our Department of Defense, our land disposal. We're getting into cannabis these days. Irrigated ag. So there's lots of different programs.
Is the private contractor manages this, or state board manages this one?
So we manage the database. The private contractor sort of does. We have basically a programmer on staff that will make changes to the system, create new reports, generate new reports, new forms, things like that. So
the reason I'm asking this question at Matt is for the audience. California has this system called GeoTracker, which originally came when the MTBE was an issue. It actually started in Region 2. We were trying to put circles between a gas station and circles between a drinking water well. And when the circles came together, and at the time, contract was given to the Lawrence Livermore lab, and Michael used to work there, and then it eventually evolved into a GeoTracker system, which is a very good, robust system for tracking. So it's very hard in California today, things to fall through the crack of all these institutional control obligations. But some of the obligations that Matt said about vapor mitigation, for example, what if the day before Christmas, the alarm system didn't work, and for 5 days there was no ventilation, and does that, I don't know whether GeoTracker can even capture that one.
No, and I think that our regulators are becoming increasingly weary of those types of mitigation measures. That if there's continuing maintenance or even the vapor barrier, what are the long-term performance of those vapor barriers? And so I think as a general rule, and some regulators, some areas are more conservative than others, but I think that, like in our San Francisco region, they're tending to move away from any of those.
Is state thinking of upgrading GeoTracker into a full institutional control tracking system?
Not specifically.
Hannah, any wisdom from you?
Not quite as advanced as the GeoTracker. We do have we have an interactive GIS map that the public can access through the internet, and it contains all closed events and the risk-based closures. It also outlines some of the information of the closure itself on that. And that's kind of what we expect the public to look at to do their due diligence if there's any type of construction or redevelopment. We also have the utility notification program, the Call Before You Dig, that we're a member of. And if there's a construction going on, we're notified if they're going to be in the area that some of our risk-based closures are. And so we can address where those locations are with them and work with them if there's any risk associated with their work.
So if I send a report to you, is that report immediately uploaded into some system in state of Colorado?
So the report itself is only accessible through a file review request. We're actually in the process of trying to update that to make it a little bit more accessible to the public. So a file review request isn't required, that they can just access it themselves. And that's a program we're working on getting running. But at this time, they would have to do a file review. The map itself gives a limited, more of a summary when there is a risk-based closure at a specific site. So they can look at the map, identify an area, and it'll pop up whether there was a risk-based closure on a corner that they're working on.
Good, Laura.
Oh, Missouri also has an online Google map that you can utilize. It's called eStart, E-Start. It's a Google map. It's somewhere between Colorado and California on it. It's like a mini GeoTrack maybe. We do have attached to the barrels that indicate that you have a tank site. If there's a no further action letter that's been issued, that is the downloadable item from our map. Also, we have restrictive covenants that are downloadable on any site with restrictive covenants. And they do put on the map the extent of any area that's restricted. If there's specific areas, especially for Superfund sites and federal facility sites, those property boundaries are notated. But it's similar to theirs. And no, we don't have documents yet, but we are hoping to someday when funding is available to be able to have full documents. Currently, we just have the restrictive covenants, the no further action letters, and we try to put up a map showing the location of any monitoring wells or things like that that were present when the site was closed. And our map does include not just cleanup sites, but all gas stations, current with or without releases, and all the cleanups, whether they're in process or finished.
Okay. Drew, I want to take one more question. Or how's the timing? With 10 minutes left, do you want to take over, or shall I take one more question?
Why don't we do one more question?
So, can you go to number 9? Okay, the last one. What public notification requirements are utilized in each of these 3 states before you can close? Because obviously you're closing sites in California, 3,000 ppb benzene, 1,000 feet MTBE plume, and so obviously your legislature would require some kind of a notification. I like to hear from the 3 panelists what kind of notification the citizens are made aware of before closing these sites. Matt?
You guys want to put number 9 up on the slide there?
Is it not?
No.
On our screen it is.
Why don't I go ahead? I'll pull it back over here. See if I
Okay.
can get it up.
So in California, before we close a case, we have a 60-day public comment period. We propose a case for closure and send it out to the responsible parties, the property owners, any impacted property owners, tenants of those properties, surrounding property owners, so any property that is adjacent to the property that's impacted, and their tenants, water purveyors, so any water purveyor special act districts. So in California, we have these special act water districts, building departments, tribal authorities, and any other interested parties that have requested to be notified of case progress along the way. And then our closure decisions are also posted on our GeoTracker database and then our water board's website.
Do you send this, or me, the PRP, has to send it?
So the state board, when we close cases, we send it. Some of our regional boards ask the consultants to do it. I think that we don't necessarily agree with that practice.
So this is, you are intending to close, so you send this to everybody and say, we don't hear, in 60 days, we are planning to close this.
Yes.
I see. That's how your rule is written.
Yep.
I see. And then a water district calls you and says, no, don't close it. What is the arbitration allowed for there?
So then we have to consider their comments. Did they bring up any new information? Did they bring up any valid concerns? Are there things that we didn't consider? And so if they bring up something that changes our opinion, then obviously we don't close the case. But if they don't bring up anything that changes our opinion, we respond to their comments, and then we send it to our executive director to decide, okay, are we going to close this or not? And then he...
Do you put this in public library?
Yes. Okay. Well, in California, there's a new web accessibility law. And so prior to July of this year, we posted public comments and our responses, but we have direction based on this new accessibility thing that we no longer do that.
Hannah?
In Colorado, we provide a 30-day notice, identifying the contamination that will remain in place prior to issuing the NFA. Those closure summaries get sent to all property owners with an impacted or threatened property, and then they have that time to respond, to ask questions or request additional information. Like Matt was saying, if they bring up something that hasn't been addressed or a concern that they would like to be evaluated, then we may extend the project. But if everything is eliminated, then the closure would go through at that point.
Good. Laura?
Well, we don't have a law like that. We don't have a law that requires notice before we close the site.
Do you get complaints after closing it?
Not usually.
Very simple. Good.
Yeah, it's pretty straightforward. It's the way that it's always been handled here. The only public notice we do is with regards to corrective action, and only for those property owners that are directly affected by the corrective action.
Drew, we have 6 minutes. Do you have any questions from the audience?
Yeah, let me pull one more up. One was kind of a quicker one, and then did we kind of have one that was outstanding from last time? Did we get number 2? Let me pull this up. Second question.
6 more minutes.
Yep. Yeah, and my closing will be very brief. So yeah, there was kind of a follow-up to the first question there. We had that second one, and then there's a third one from the audience. That Matt, I think it was you that was speaking a bit about the de minimis concept. I don't know if that's an easy thing to answer here as far as a definition, or if that's something that could be provided after the fact, and I could post it. But here's what we've gotten from the audience throughout the webinar. So if there's time to cover any of these quickly, that'd be great.
Can you take over the screen and post the questions?
Do you not see that?
No, all we see is, we see the slide 9. So you want to just read the questions and we'll...
Yeah, sure. So one was following de minimis. Can we see the definition of de minimis for UST program cleanup of non-petro contaminants?
It was kind of what I mentioned there, but I'll send it to you, Drew, and then you can send it out.
That sounds great. Thank you. And then the other one from previously was regarding closing a site with free product and using LNAFL transmissivity as a line of evidence. What level of rigor do you apply to the transmissivity values provided by the contractor? For example, how many samples at the site, et cetera?
I think Hannah answered that very well. I think she gave a good description of what they do in Colorado. I think.
And I think in California and Missouri, we don't really rely on transmissivity.
Because they have other criteria, qualitative criteria for that.
Well, that's all I've got from the audience. I can give it like 30 seconds if anyone's got maybe one they're sitting on. I've got 2:53 on my clock here, so I'll just give it 20 more seconds if someone wants to fire me something real quick. Otherwise, we'll wrap. We're not, unfortunately, going to get to the case study that we had waiting in the pipe. If we had time, we don't. But I can circle back with Matt if it's in what we feel is a readable format. I don't mind posting it if it's okay with you, Matt. So we can circle back on this de minimis definition and the PowerPoint. If you think it's helpful to share, we could do that. So I don't see any questions coming in. So let me just go ahead and switch to my closing slides. Are you all seeing these slides?
Nope.
Here.
I see them.
I think we got disconnected on the internet.
Okay, that might be it. Laura, Hannah, you guys see those?
I can see it.
Okay.
Yeah, looks fine to me.
Okay. I assume the audience can as well. Well, we're going to wrap there, everyone. See if I can advance my slides here.